Hi class, in this video we're going to talk about translations. We're going to be able to describe translations using vectors and graph translations in the coordinate plane. So this video is just going to focus on vectors, what they are, and how to use them to describe translations. Then in class we'll actually be graphing translations. So first, some quick vocabulary. What is a translation? A translation is an isometry which moves all points of a figure the same distance in the same direction. This is also known as a slide. So pretend that you were at the top of this slide and then you slid down to the bottom. You didn't change, your shape didn't change, the size of you didn't change, just your position changed. So whenever we're graphing translations, we're going to have a figure and then we're just going to slide it across the graph to a different position. A vector is used to describe a translation. You're going to use an ordered pair that looks like this. You do not use regular parentheses, you use pointed parentheses for vectors. Think of a V, and it's like a sideways V on each side for vector. X is going to represent how far you're changing horizontally. So if X is negative, you're moving to the left. If X is positive, you're moving to the right. And then Y represents the vertical change. So if Y is negative, you're moving down. If Y is positive, you are moving up. So let's practice using vectors. Describe in words the translation represented by each vector. So whenever you're looking at a vector, remember X is left or right, Y is up or down. So 2, 5 is telling me that I'm going to move 2 units to the right and 5 units up, because they're both positive. The next one, -3, tells me I'm going to move 3 units to the left, and +8 tells me I'm going to move 8 units up. Describe each translation using an ordered pair. So now we're actually going to write our own vectors. If I'm told to go 2 units to the left and 1 unit down, well, left has to be negative and down is negative, so this is going to be -2, -1. 8 units to the right and 10 units up, those are both going to be positive. This will be +8, +10. Make sure when you're writing a vector that you're using these pointed parentheses. If you just used regular parentheses, that's just saying a point on your graph. It's not saying that you're moving around the graph. In the diagram, find the image of point Q under the translation described by the given vector. So what these directions are telling us to do is they're telling us to start at point Q, then follow the translation to the next letter. So if I have to start at point Q and my directions are to go 2 to the right and 2 up, 2 spaces to the right and 2 up, I'd be at point R. Next, I'm starting at point Q, and I have to go 2 to the right and 4 down. So I'm going to start at point Q, 2 to the right, 4 down, I'm at point T. Now I'm starting at point Q, I'm not moving to the left or right any, and I'm just going to go down 5. That's going to lead me to point U. Find the vector that describes each translation. So we want to describe how we're going to move from T to V in this graph. So here's T, here's V. I have to go to the left or right first. So I'm going to go 1, 2, 3, 4 spaces to the left, that's -4. Then up 2, that's +2. So the vector is -4, +2. Number 9, R to U. I have to move to the left, 1, 2, then down, 1, 2, 3, 4, 5, 6, 7. So this will be the vector -2, -7. Make sure you always are listing the X value first. That's the most common mistake I see, is that people will try to list the Y value first, going up or down. You have to go left or right first. Now we're going to write the component form of each vector. So in each picture, we're starting with a letter, then it's pointing to another letter. So we're just going to describe the translation from Y to X. So we're moving to the left, 1, 2, 3, 4, 5, and then we're not moving up or down any, so that's just going to be negative 6, 0. Hold on, let's recount. 1, 2, 3, 4, 5. My bad, that should be negative 5, 0. Ignore that. Next one, we're moving to the right, 1, 2, 3, then up 2, so that's why it's 3, 2. And then the last one, you're going to move to the right, 1, 2, 3, 4, 5, 6, and then down 3. So that would be positive 6, negative 3. We're actually going to look at shapes on a graph now and describe the translation. The dotted figure is a translation of the solid figure. Write a rule to describe each translation. So we're going to start with the solid figure and we're going to write a translation on how to get to the dotted figure. To do this, you're just going to pick a point on your solid figure. I'm going to pick this point right here. And you're going to pick the corresponding point on the dotted figure. That would be this point right here. So to go between those points, I have to go 1 to the left and then up 3. So that would be negative 1, positive 3. The second one, you're going to need to go to the left 1, 2, 3, 4, 5, 6, and then down 2. So that would be negative 6, negative 2. It doesn't matter what 2 points you pick. I could pick this point too. It's still 1, 2, 3, 4, 5, 6, and down 2. And the same thing here. 1, 2, 3, 4, 5, 6, then down 2. You just have to make sure whatever point you pick that you're picking the corresponding point on the dotted graph. That's all for today. I will see you in class.